hit the record button. I've hit the record button now. You can go ahead now.
Okay, Judith. So I'll just do a little recap, right? What we were saying last week. We were going through
Hmm.
Judith samples. We were looking at the Haney test, which is a test designed by Rick Haney. It looks at lots of different data points to come up with the kind of soil health score. We were looking at organic matter loss and ignition. That looks really healthy in Judith's fields. We were looking at CO2 burst. So they dry the soil, they wet the soil. In 24 hours, they collect the CO2 as an indicator of microbial activity. And we got some really cool high scores in some of Judith's field, and that correlated with not ploughing, right, Judith?
Yeah, that's fields that haven't been, well, they've not been ploughed. One of them might have been ploughed in the mid 1990s, and the other one hasn't been ploughed since before 93 when we came here.
Right.
And been paddock grazed for the last, well, since 2019, 20, 21, 20. So 19, 20, 20. The last 5 summers it's been paddock grazed rotationally. So and actually the levels, I find it interesting because the lowest level there is the field that was ploughed this summer.
Hayfield, is it?
Yep, yeah, that was ploughed this summer. And then, in fact, well, when the way we do it here, it's ploughed to be put into forage rape, and then the next spring it's ploughed to be reseeded. So it's actually ploughed twice. But so that's the result after 2 ploughings. And then the cathedral field 1, 2, and 3, the low one is that super soil stuff that the Irish.
Yeah, the top 3 were a trial, right? And you had Johnson bioreactor versus super soil, which is a product in the UK, and then
a control.
A control plot.
Yeah.
So yeah, that's pretty cool.
I find that really interesting, just to see what the carbon levels are under, what.
Yeah, so the respiration is lowest, and also the organic matter is lowest, which could indicate that maybe some carbon got burned up in that plough event, particularly in such healthy soils, where with high respiration, when you plough, there's going to be a lot of activity, I would have thought.
Yeah.
I read a paper where legumes after ploughing got more nitrogen from the soil food web, from nutrient cycling, than when under no-till conditions, the legumes got more nitrogen from fixation. So kind of affects the crop as well, affects the physiological processes that are going on.
Yeah, the processes under which they access the nutrients they need. Yeah, it makes sense though, doesn't it? When you think about it.
So that's kind of cool. That kind of matches up. Also, I'd like to point out where you got like nice respiration in those 600 ranges, and this 340 here. You've got a more desirable pH range, and I've kind of seen that in my small experiments in pots.
I don't understand how the pH ranges are what they are, because given when we test for pHs on the Scottish system, so to speak, we get to a high of 6.3 or maybe 6.4. These pHs are a lot higher than what I would have expected, like a lot higher.
Because I'll take a note, and then I'll ask them how they, what they're using for that.
Yeah, I mean, we're acidic here, and I mean, we would always try and get the pH up to 6.3 or 4 if we could for planting the brassicas. But I mean, from our point of view, getting it to 7 or 7.2 is overshooting the mark, and we're putting far too much lime on, and it's costing us, we shouldn't need to get to that level to get a decent crop of brassica.
Interesting.
So I don't know.
So you think that's a bit different to your historic?
It's different from the pHs that I think. I wonder if we did a pH in these fields, what we would end up with. If I did a traditional Scottish pH.
Yeah.
Example.
Maybe there's a different method.
Yeah, I don't know. Yeah.
But you said the organic matter kind of matches up roughly historically.
Yeah, it's not far
like I said before, this is loss on ignition, which is maybe a little bit higher than if you did it the Dumas way, but not far.
Yeah.
Okay, where there's also these nice respiration ranges that are in the kind of very healthy range, there's also seems to be the highest soluble salt. You got this.
And is that actually sodium chloride, or is it some other salt?
No, it just means all the soluble.
All the
it's
salt.
like an EC rating of the soil, I think, for soluble salts.
Okay. Right. Okay.
So, yeah. So we noticed that there's a bit more where the respiration is higher, and you get a higher soil health score. There is also maybe higher minerals present. We saw high potassium, right? And we saw pretty abundant organic nitrogen and organic carbon. So we also talked about this test and how it takes into account water soluble organic carbon and water soluble organic nitrogen that are, they go into the soil solution, and the microbes can use them. They're micronized, they're on the level of the microbes as a food source. Whereas this kind of bulk organic matter is more like an environment, more habitat space. The water-soluble organic carbon is more of a food source. And the water-soluble organic nitrogen, again, a food source that can limit enzymes if it's deficient.
That's like the immediate food source rather than
a
longer-term source. Yeah.
Yeah, like for the organic carbon, if you pour on ionic nitrogen, or you plow, or some kind of event that's going to excite microbial activity, they're going to grab at carbon. And that first carbon they see is in the soil solution, is that water soluble organic carbon. If that runs out, they'll turn to this organic matter. And as that slowly runs out, we destroy soil texture and nothing works.
Like in compost, basically, we get the compost heating up, but basically the everything is consumed, right?
Yeah. Okay, so we also talked about the ratio between this water soluble organic carbon and nitrogen wanting to be between 8 and 12 on this scale right here, and that ratio is around 10. So right smack bang in the middle of that ratio. It changes a bit, but not far off, and right in the middle of the good kind of target range. So when respiration happens, they capture that carbon, and then they measure that against the water-soluble organic carbon, and it gives you this microbially active carbon. So it shows you the amount of carbon that's in the soil compared to what's being respired. So, for instance, in these healthy ones, there is 200% of the carbon that was captured in the respiration event present in the soil. In other words, there's reserves there. There's a lot of carbon reserve. There's a lot of water-soluble carbon reserve. So that's something to track over time. And he says, as as soils get healthier, they respire more, but also there's always a lot more carbon in the reserves, which makes sense, right? So, and that's fueled through healthy decomposition.
Yeah. So that's like good cycling.
It's basically, good cycling has happened for a long time, and it's built up this bank, kind of like compost in soil, like a bank of organic matter that's decomposing in a healthy way.
Yeah. So again, the super soil bit and the field that was last ploughed this summer are the ones with the low scores.
Exactly. Yeah.
So the super soil one hasn't recovered from the same treatment that either the Johnson Sioux area or the control area. It's actually worse than the control.
That's what it looks like. Yeah. But this is a very limited data set, so it's hard to say that. But, from a shot in the dark, it looks like you're not doing any damage by doing Johnson Sioux at all. But, that definitely came up a bit lower. And the one that got ploughed is much lower, right?
Yeah.
So it's respiring a lot, but the reserves have been burnt up, which is very, it really matches your historical view, which is you just ploughed it,
Yeah.
We might have burnt up some of the reserves, but it's respiring a lot because it just got cloud. Well, compared to the reserves, basically, in that ratio there, we're getting.
Yeah, it's burnt a lot of what was there up and it's gone. Yeah.
Yeah. So I just, like quickly, Haney likes to use this if he's designing cover crops or like things to stitch into pasture. He'll plant like a little block of whatever it's going to be, white clover, and then plant a block of chicory and then a block of whatever else, and pull the cover crop species, pull the soil from the roots and see how the species affects the soil health of your soil. And he finds that in different areas of the States, they get different plants that have the higher scores. Often in where he's at, it's sunflowers. They make the soil healthier faster, and they're native species there. So, makes sense, right? Just thought I'd add that because it's a cool way Rick uses this test. So, did you see anything else while you were looking, Judith? While you've been reading through the interpretation guide and stuff.
Yeah. What I really wanted, my main question was, it gives you levels for different minerals, calcium and magnesium and all these things. And I've no idea what levels.
Yeah, about targets for them.
Yeah, what a target range might be and whether there's something, a balance that's out of balance.
Yeah.
I mean, particularly, P and K. I know the phosphate's pretty high. Was it the phosphate's pretty high?
It looks high.
I've been trying to say to Tom that we can take a phosphate holiday, but it doesn't.
I think you can take a phosphate holiday as well. Yeah. I mean, nitrogen, in its ionic form, it moves through the soil quickly, or it can do. And in your situation, the bulk of the nitrogen has been held as like amino acids. But phosphorus, the iron doesn't move through the soil much, especially in a healthy soils like yours. So it's cool that you have like nitrogen pulled as amino acids and proteins, and then you have quite a good pool of phosphorus, which is in the ionic form. So you have kind of really cool balance there. So both nitrogen, you've got a lot of credits on this score, on this test for nitrogen and for phosphorus. And where it's healthier, you've got massive amounts of K as well. So that I think that nutrient cycling and the better rates of decomposition really help with the access to K, because it's just held in the matrix of the tissue, like the necromass. And as that necromass, the tissues of the plants and stuff break down, that K is one of the first things that comes out. So when you make a compost pile and you put it together and get it cooking, and then it's finished, if you test that pile for like available stuff, when it's done, it'll be quite high in K. And as it gets older, it will balance and become more calcium will come out of the wood chip. So I think this higher K is, just another proxy for healthier soil, more nutrient cycling, higher potassium, right? So where you haven't plowed for ages, you have a higher credit for potassium. And in this 600, you have quite a high phosphorus. This is available P as well. So this is, I remember on your traditional soil test, you had quite high phosphorus. Like I was, remarkably high. Yeah. And on this available one, I would say this is quite high phosphorus as well. Yeah. But I don't have much of a metric for this test because we haven't done it a million times, and I didn't do training with this test. I've just kind of, read everything that's out there, and we talked to Rick Haney and Lance Gunderson for an hour about it.
But where it says the difference in nitrogen between the Haney test and the traditional, that's and they're talking about their savings. Is that pounds per acre?
No, that's still dollars per acre.
No, that'd be the savings, isn't it? No.
Oh, sorry. Yeah, sorry. The savings. Yeah.
But
the pounds per acre. Yeah, you're right. Sorry.
Pounds per acre. So I then can work out what it is going to be in kilos per hectare for my own use. I can work that out.
Yeah.
Yeah. Right. Okay. That's fine.
Yeah, I mean, this is made by American Metrics as well for the savings, so it's maybe a bit different.
Yeah, but and I mean, I'm only, this is my first time looking at it, and you know, if it says it's got 80 pounds per acre, I mean, I'm not. Would you actually reduce your nitrogen application by that whole 80, or would you reduce it by a percentage of that? You know, if
you take that off the amount that they think it takes to do the thing you want to do. So you figure out the best guess for the UK on what's the thing you want to do, what's your level of production, and what does that take for these different inputs, and then you can minus this Haney test N off that to get the best idea.
Yeah. So I mean, I don't know, but pounds per acre, if you were to swap that to kilos per hectare,
it's not a million miles away from 1 to 1.
Well, I was going to say that. Yeah, we kind of worked that out last week, didn't we? But I mean, if I'm not even putting on 80 kilos an acre, 80 kilos a hectare, does that mean I can actually get away with doing none? Because I mean, that just didn't work this year. We reduced the
because this isn't the Haney test when it goes into full drought mode.
Yeah,
this isn't what the Haney test looks like then.
Was it the lack of nitrogen that was doing the damage, or was it the drought? The other thing I wanted to say, Adam, was the soil samples I took were not 6 or 8 inches deep, because we don't go that deep.
Yeah, right, because you got bedrock not far off.
Because you go down I mean, you might get down 2 inches one time, you might get down 4 or 5 the next, but
just because the bedrock's so bumpy and
it's not bedrock, it's just stone. It's just the amount of stone that there is there. I actually ended up, I went out with a glorified sort of strong spoon rather than
that's a big thing,
because I just trying to do it with a corer or something like that, I just don't have the energy for that.
These tests don't calculate stone. That is a great point. And that's the thing that came up in with a guy that came to see us on, who was working with vineyards in like Kent and in Oxfordshire, where they got lots of stones. That you have to calculate that, because that's a dilution effect when you've got that stone there. And if you're calculating these things as if it's just a straight up field with nice consistent soil, the reality is a little bit different.
Right. So if I say it's roughly half stone, then instead of having a difference of 63 pounds per acre, I probably should half it.
You could say that, yeah. If you could dig a trench, or if you just know that confidently enough to say that, then I'd say that was.
If it's not pure soil by any means.
That's the range to consider, from half that to that, depending on your good areas to your bad areas, more stony areas to better, more.
Okay. No, that's a sensible way. I just wasn't sure about that. And then when it says the cover crop mix that they were, recommending, that's more or less what we plant. That's what when we're
already doing it.
We're already.
Judith, where's your book?
Eh?
Where's your regenerative agriculture book?
How do you mean?
You need to write one. You're doing all the right stuff.
I don't know about that.
It's gonna be Gabe Brown, Eat Your Heart Out. That's what it's gonna be called.
Well, he's cropping. I'm not.
Show these Americans.
We're in a completely different situation. The only crop we have is 1 8 or 10 acre field of forage brassica a year, and the rest of it's all grass in some form or another. But they
keep a record of this for a short time, and you can get recommendations from them for what they would do. But I think we've arrived at a sensible way to look at it, considering your rocky situation.
But no, I've really to have an idea of the the different minerals. That was what I was. But I don't think there's any huge. It doesn't seem to. Does it have anything about sulfur in it?
It's on here, isn't it? Yeah.
Let
me. Yeah.
Because
perhaps actually, this whole thing about your volume of the soil might require a good thing in comparison to what their assumption is. If they assume these numbers per acre or per hectare, right?
Per acre slice, I think.
If they do it per acre slice, but they tell us to do what, 4 to 6 inches?
6, yeah. I think.
Oh, something's going.
Then basically, sorry, Judith, can you hear me?
Yeah.
Okay. So if they are assuming that you're sampling to 6 inches, they're assuming a certain volume of soil in an acre.
Yeah, exactly.
And so then two things that reduce your result is the stones and the actual depth of your soil, right?
Yeah.
But then suddenly, basically, your volume is 1/3 of that. So basically, then you have to divide it by 3, and then you've got 50% of stones. Then you divide that again by 2. Suddenly, your value of what you've got per acre there is actually divided by 6 of what's in that result. I think there's a conversation to be had with Region Ag Labs to make sure that we understand this correctly.
Yeah, I remember the guy from Future Grow had his program.
Yeah, I think I need to think about that and maybe go and dig some holes and just see what I think, to 6 inches in different places and see what we come up with for because it'll be in a volume thing, will it, rather than a weight, won't it?
You can do it both ways and figure out, but yeah, volume probably a bit more relevant.
Yeah, right. Okay. Yeah. So I'll think about that. But yeah, I wasn't inclined to say that, there's a saving of £80 an acre and just to say, right, we cut applications by 80. I was going to, half it or something. But if I should third it, maybe that's a sensible thing.
Yeah, I think the important thing is, you've got more where it's healthier and you haven't ploughed than you have where you ploughed. And seeing getting this visibility is quite useful. Like you said, sulfur's low, which is common for every agricultural soil.
Yeah.
So that could be added. Let's have a quick look at other stuff. I mean, there's room for calcium, so you could add calcium sulfate. They do magnesium. Yeah, they must do this there. Yeah, and my soils that I've been managing and looked at with this system, I've got much higher sulfur, but I've used a lot of calcium sulfate, so that's why.
And what about the sodium? What's that like? Because when we did tests before, sodium was very low.
Yeah, again, we haven't much reference point for this type of sodium, but it looks low to me, yeah. Because sodium by nature has an affinity with water, right? So I'd want to see.
It'll wash out quite easily, won't it?
Yeah. So I think that's low, yeah. Definitely compared to a traditional test, that would say that would be less than 1.5% of a base saturation, maybe.
We put on, I can't remember, was it 50 kilos of salt an acre or something? It was quite a small amount.
Yeah. Grass loves sodium, it seems.
And, it really made a difference to the palatability of the soil. And the guy that was telling us at the time, he's an old guy from Cumbria. He said we need to do it again, and we never have.
Yeah.
But, I do wonder if it's something we shouldn't just do.
I think maybe that's good, yeah. Because when we look at lots of arable, like I've looked at oats and wheat now, and they it's low sodium, low chloride. So you're never going to do damage, I don't think, with putting a bit of salt on. I think it's just good for the animals. It's got a lot of cool trace minerals in it, rare earth elements, like free stuff, not just the sodium chloride, but other good stuff.
And actually, I think the cattle especially, but probably the sheep as well, but the cattle thrive much better if they've got a rock salt lick to lick. Mm-hmm. And like out in the hill in the deferred grazing, right out at the back of the hill where half the cows are at the present, they've just gone out there in this last month. Last year when Duncan took them out, they just didn't settle. And eventually I said to him, have you got rock salt out there? He said, no, I haven't. So he took it out, and the next day he went out, they were just calm.
Yeah, wow.
I just wonder if there's something in that rock salt, whether it's sodium or chlorine or whether it's something else that actually helps the rumen operate better.
Probably. But yeah, I mean, where you're on hills, and is he on hills as well?
Yeah.
Yeah, and the rain comes down and washes that salt away, just the sodium alone is needed. So I think sodium is a good shout, and it's cheap, right? And I think you might get, people even see an uplift with grass with sodium. And then magnesium, sulfur, there's room in calcium. In the fields that aren't reading as healthy, there's probably room for potassium. So that could be polysulfate. There's a new mine that's in the UK, and it's a raw material. It doesn't need any processing, and it is calcium sulfate, magnesium sulfate, and potassium sulfate.
Polysulfate, just a minute. I'll write that down. Sulfate, calcium sulfate, magnesium sulfate, and
potassium sulfate. And that's all in like a complex mined in Yorkshire, I think. I've actually got the guy's card if you want me to try and maybe we can get some free stuff.
Just ping me a WhatsApp with it or something.
Okay.
Yeah.
You might be able to do a trial with them because they're quite new. They're trying to get farmers to use it. And in your situation, looks like it would work with a bit of salt. That's maybe quite cheap.
Yeah. Mm-hmm.
And maybe you wouldn't have to. Let's have a look at, like, potassium's higher where the respiration's higher, so it's needed less. Sulfur is just needed across everything, though. So
you
get some benefit from it there. Magnesium looks, it's a little bit higher where the respiration's higher. Quite a lot higher, actually, but
well, we put on magnesium lime for ages.
Okay.
And latterly we've changed to calcium lime.
Right.
Just because we realized, well, you just think you're doing the right thing putting lime on, and then you realize, oh, it's magnesium lime, and then they start talking about soil structure and all the rest of it. So we changed at that point to put calcium lime on. So yeah.
If you did a traditional test, the calcium is always higher on the traditional test, from what I've seen. Like the exchangeable pool of calcium is higher than what this test often shows. So the plant exudates the H3A extractant, which is meant to mimic the plant exudates. It sees a smaller amount of calcium than the other tests. So that's why the number looks kind of smaller.
Right. Okay. And what about the likes of manganese and?
Again, it looks.
Iron's not going to be a problem, I don't imagine.
No, again, it's in a healthy soil in UK soils. Iron is just abundant. It's just when the biology starts to break down and you don't get so much iron. But even on hayfield, it's not the worst score. So iron is definitely abundant. Grasses usually produce siderophores, microbes produce siderophores. They make iron available. I don't think you'd need to add iron.
Mm-hmm.
Yeah, it's just that sulfur. I don't really, maybe zinc, but maybe not. I'd start with the ketones, the polysulfate and the sodium chloride, and salt, and I'd start there. Yeah.
How do I work out a rate of application? How do I even start that?
Yeah, I mean, we need to figure out your bulk density, which is if you do a weight by weight calculation, Yeah, you need to know your bulk density. So if you get a known amount of your soil, dry it down in the oven and let me know how much that, if you take 1 cup, dry it down 100 degrees for overnight or something, make sure it's nice and dry. Put it into a known volume and then let me know how much that weighs per that volume. And I could do something that looks sensible. You could also talk to the polysulfate people to make sure.
And do you then
ridiculous.
also need to know how much of that there is per acre in the same way that if your stones for your nitrogen?
Yeah, because this is ppm. It's quite easy to do grams, weight by weight calculations. Like if we know there's so much potassium, so much calcium, so much magnesium and sulfur in this polysulfate product, like elemental magnesium, then we can do a weight by weight calculation.
Right.
So I could do a rough one that would be,
Yeah, we don't want to be orders of magnitude too high or too low. But I mean,
exactly,
if we're somewhere in a ballpark figure,
for
then
sure. Yeah.
Right. Okay. Yeah. And do I need to do each field differently, or will the density of the soil be similar across the farm?
If you have any, we could look on the what's it called, the geological survey map, and see how variable your geology is. But do you know the kind of geology? Is it all very similar?
I think it's fairly similar.
Yeah, it's just kind of the lay of the land that might change a lot, like the steepness of the hills and stuff.
Yeah, and there's 1 or 2 fields that are more stony than others.
Yeah. Yeah, it's worth considering them if they're more stony, to maybe be a bit cautious with these credits you've got.
Yeah.
Yeah.
Okay. Yeah.
Think about that.
Mm-hmm.
We've seen, for instance, in our wheat trial, the field which we did our wheat trial in used to be a flint quarry, and or gravel quarry actually. So there's a lot of stones, a lot of flint in there, and we found at the bottom of the hill, where the biology was applied, that was probably the weakest growth. And still where chemicals were applied, next door, 2 meters away, that was still growing. There were patches where it was not growing, but it was still growing. And, we sort of just called it outdoor hydroponics, because literally it was like a loose medium where you just added some soluble nutrients and things could grow. But for biology to establish, you actually have to have actual soil.
You have to have something there for it to establish in.
Mm-hmm.
Right. Okay.
Sure.
Mm-hmm.
That was really bad, though, at the bottom of the field. Might as well grow succulents when it gets that bad.
In Saudi Arabia.
Yeah.
Right. Okay. I think that's most of my questions answered.
Yeah, I think you've got a better idea of what's going on.
I think it was good doing a good few in one go, because I feel I've learned more by comparing the fields and knowing what the history of the different fields is.
Absolutely, yeah. That's super interesting how it lines up with you.
I did kind of choose them to give a bit of a range, just wondering what would turn out. But I wasn't expecting it to be, to work out the way it did. I don't know what I expected, but I just thought I would try.
You never know, do you?
Yeah, I would try different things to see the difference. I'm now quite keen, actually, to go and, when we pick our field that's going to be put into forage brassica for next year, I'm going to test it before, each year, and see what the effect the first ploughing has on it, and then the second ploughing. I'll just let them do it and plough it, and then we can see. And then after that, I'll maybe say to them, look, I don't think ploughing is a good idea. We probably could do without, cut out at least one ploughing activity and maybe a second one, but just to see what it does to the field. I just think that's quite
before you do that, get yourself a gold standard test on the carbon content of that unplowed field. And then do the same test afterwards, and then see if if the plowing actually removed your carbon from the soil and how much, and then compare how much it is worth on the open market. Because they're going in that direction, and obviously tillage is actually what releases the most carbon from the soil. So already you're seeing here on those results that you're actually holding more nutrient if you don't plow. And the other thing is that, you know, if this whole thing progresses and we're going to have carbon credits in the soil, maybe even in a few years' time, maybe sooner, maybe later, doesn't matter, but basically they're going to have a value. And then suddenly you're already showing that that you can store carbon. The moment you plow, you negate that value.
Yeah. You take several steps backwards, don't you? You undo the
But this is gonna be monetary steps, literally.
Yeah. Yeah. No, that's really interesting though. Thank you very much.
Cool, yeah. Just seeing here, we've got this higher organic nitrogen release where you got more respiration as well.
Yeah.
Daniel's actually been talking to a company that make fish hydrolysate, and I think they're up for a trial with our product. So maybe we could use some of that. Certainly, I think where you've got these higher organic M releases, those kind of products would be more useful. You get more out of them.
You get more out of the fish hydrolysate.
Yeah, where you've got these higher N release rates because that's coming from the organic pool.
So does that mean there's biology there to release it? Is that what you're saying?
Yeah, exactly.
Because you need the nutrient pump to be working. And if you've got something like, you know, the fish hydrolysate, which has got still N that is just attached to the bigger molecule, you need the biology to release it.
Yeah.
Because fish amino acids are animal aminos, right? They're not plant available. Plants don't use those animal aminos. They have to break down and then get built back up again. And, you know, if you spray that fish hydrolysate on some pretty dead soil, then it's going to help with regeneration, but the plants aren't really going to get access to the nitrogen as fast as they will do in a soil like yours. Well, these healthier ones in particular, you know, you get much more efficiency from that organic product.
And for everybody else, get some of our goop, and that basically provides the nutrient cycling.
Yeah, for real. Yeah.
Well, I've got my Johnson Sue's. I've got one that I've been using, and I'm going to be using it. I'm going to put some of the Johnson Sue extract onto the straw in the bedding, and then put some also. We've got a tank where the piddle runs up front, is drained off from behind the cows that are tied up in the shed. So I'm going to put some in that, and then some in the straw bedding for the wean calves. But I mean, most of it will actually be used next spring, and I've got, there's another 4 or 5 Johnson Sue's to use next spring. But I've also set up some 4 220-litre barrels of Super Magro.
Oh, yeah.
And I've got a JLF of herbal grass mixture, and a JLF of 2 lots of JLF, and I've set another one up, so come 2025 it'll be a year and a half old or more than. So I need to work out how I'm going to use that.
Yeah.
Come the time.
Well, you know, if you do more of these tests, it gives you a better idea. So, for instance, say there's a time of year where the water-soluble carbon and nitrogen run low. Maybe, you know, I don't know what's going on. Maybe like, if you read the interpretation guide, it kind of roughly takes you through an annual process and what things that might affect. If we can determine when those resources are low, maybe a big dump of these kind of water-soluble, you know, because JLF is basically water-soluble carbon and nitrogen plus some of the minerals, you know, you've kind of hydrolyzed that stuff down. So maybe that's when it could be most useful, when these things are lacking in the soil.
So I need to repeat these tests at different times of year to understand when the point of restriction is.
Yeah, exactly. You know, like in stressful times or in just different times.
Yeah. Okay, no, that's great. Thank you very much. That's enough of me. Has anybody else got questions to ask?
Daniel, I've got to go in a moment. Do you want some feedback on your NutriBridge flyer?
Yes, of course. Always.
What are the blue bits?
That was my question. I asked the same thing.
This is the graph is the most confusing for most people, actually. So I'm actually redoing the graph completely. I'm just going to keep it simple, or it's going to be, you know, just a regular sort of yield after glyphosate, and then one where basically you use the biology, which should unlock a decent chunk, depending on the soil, depending on conditions. The blue graph actually comes from the same trial. This was on the pasture trial where we first observed this. That was actually the plowed strip, and there was no detrimental effect on the growth of the plants like there was with the glyphosate. So although plowing basically is what releases your carbon, destroys your system, in that particular case, you know, it's still, there was no detrimental effect on the growth of the plants. Whilst where glyphosate was added, there was a marked difference in the biomass, and only where biology was added, there was really no difference in terms of the biomass. So that's why we're going to the market with this idea of replenishing the biology that was damaged by glyphosate, so that what was supposed to be doing the work is doing the work. So that blue bit basically is what could have been.
We're simple folk. You're very close to all this. It needs to be very clear, I think.
Yes.
And the other thing is, a NutriBridge will exceed 300% on winter wheat following a cover crop. Winter wheat would follow a catch crop. The cover crop goes in the winter for a spring crop.
This is a special case, I think. I think this is for people going regenerative. People who have the money to go regenerative, and they decide to basically to have a cover crop before a winter wheat. It's not a typical case.
Okay, but again, that would, you know, if I read that, I'd say, well, he doesn't know the difference in a cover crop and a catch crop.
No.
But,
nope.
You know, again, if you, those are my comments. But
thank you.
It looks interesting.
Good. Thank you very much.
I'm going to say goodbye at this point. I'll see you probably on the course, if not next week.
Yeah, super.
Okay.
Cheers.
Any more questions? Because it's already 5:30.
No.
Nope.
I think I've done very well this week. Thank you both. It's been a huge help.
Good. And I'm also, I'm just going to mention, because we've not been doing many recordings lately, anybody who's watched it this far, this is for people watching it in the future, because I'm going to put it on YouTube. Judith has got experience with doing all sorts of preparations for her fields, and she's had some very interesting results. So I would encourage you to ask questions, and I can forward it to Judith if you want some more information, because there's some practical knowledge there. Anything else?
I'll do my best.
Judith is humble, but she's a scientist at heart, so she does things very properly. Right.
Okay. Thank you.
Super. Thanks very much, guys. That was very interesting. Bye. Thank you for doing that.
Cheers.
Thank you. Bye.
Thank you.